This video is on the pH scale. So the pH scale, pH stands for potential of hydrogen. So pH is a scale that tells us how much hydrogen ions are present in an acidic or basic solution. So our pH scale looks at the hydrogen ions in solutions, and it goes from 0 to 14. The pOH looks at the hydroxide ions in solution, and that is the opposite of our pH. So a pH of 0 is equal to a pH of 14. So they kind of go opposite of one another. So as pH goes from 0 to 7, pOH goes from 14 down to 7. And then we go by one number increments, so whole number increments. Now on our pH scale, or pOH scale, at 7, we have a neutral solution. So it's neither acidic or basic. That means that my number of hydrogens equal my number of hydroxides. So at neutral, my hydrogen ions equal my hydroxide ions. If I have something that's acidic, so something less than 7 pH or greater than 7 pOH, that means that I have more hydrogen ions than hydroxide ions. So that means that I'm acidic. Some examples here. At a pH of 0, we have battery acid. 1 is stomach acid. 2 is lemon juice. We skip to 4. That's the pH of tomatoes. 5 is black coffee. Water is usually around 7, but it can vary acidic or basic depending upon what's mixed inside of it. If I have something greater than 7 on a pH scale, that means that my hydroxide ions are more than my hydrogen ions. So I have more hydroxides than hydrogen ions. So that means my pH is going to go between 7 and 14, and my pOH is going to go between 7 and 0. So the smaller the number, the more of that ion I have. If we look, our blood has a pH of 7.4. Seawater has a pH of 8 or pOH of 6. And laundry detergent has a pH of 10.5 or a pOH of 3.5. If we're to look at something that's a base that we've learned about, so sodium hydroxide is a very strong base. If I make a weak solution, so a very dilute solution of sodium hydroxide, that has a pH of 14 and a pOH of 0. So that's very, very basic.